Driving me crazy, but anyway. Okay, so I'll get into it. Yeah. Sorry, I keep glossing over these, but these links are really useful. And I still need to update the Slack one, actually. It's got to go to Discord now. We'll talk about that in a sec. Please go sponsor MicroPython if you are so inclined. We have already gone through most of that. Barry, if you're still around, thanks again for doing the videos, and I thank you in advance for doing the videos this month as well. It's a huge help. Thank you very much. Really appreciate it. Headlines. First of all, congrats to Andrew. You'll notice Andrew Leach is not here tonight. That's because he has a little package to look after. Arlo entered the world about a week and a half ago, I guess, which probably means that his PRs are going to have to wait a little while. Apparently he's got more important things to do. Also worth noting that Andrew came climbing with me a few weeks ago and broke a bone off of his foot. So he landed a bit awkwardly and just sheared a little chunk of bone off. So as he was becoming a dad, he was also stuck in a moon boot. So that was good fun in the hospital, apparently. But congrats, Andrew. I'm sure you'll be watching this later. So yeah, good luck with it all. I thought I'd pop this up because we've consolidated some of our communications channels, and from where I sit, it's been working really well. So GitHub discussions in particular has been pretty active, and the Discord's been pretty active as well. So I think it's been a really good thing for the community to focus on sort of a smaller area of places to go to. Unfortunately, Jim had to go before, but he was on the CircuitPython show recently. So the CircuitPython show is mostly about CircuitPython, but the host, Paul Cutler's really good host, and he wanted to interact more with the MicroPython side. So you got Jim on board. I covered a lot of ground in, I think it was only about half an hour, but it's funny, I don't really hear the Australian accent or hear how quick we speak normally, but as soon as Jim came on, I was like, oh yeah, we do speak quickly, and there's an accent there, because you sort of hear it from a different perspective. But it was a really good podcast. Go over listen. You should also check out Paul's other podcast, the Bootloader, which is not so CircuitPython centric. It's a fairly short show where him and his co-host Todd Kurt, that doesn't sound right. Todd, anyway, have a twice weekly sort of maker interesting tech that's going on. It's pretty good. The Python on Microcontrollers newsletter. So Adafruit publishes this newsletter every week. Ambrella does an amazing job with it. She does really good work here. And they are 96 subscribers. In fact, I think it's down to about 90 subscribers now from 10,000 subscribers. So get on there if you're not already. I know we've mentioned this before, so I'm sure a lot of you are already, but it has a lot of news in there, not just CircuitPython, lots of everything that I send Anne, she posts. And if you want to, please tag MicroPython or CircuitPython on Twitter, or just send Anne some links and she'll publish it in the newsletter as well. I made note there that it's a separate server entirely from the Adafruit side of things, so you won't get spammed or anything like that. It's pretty legit setup. My new hardware has been a quiet month. I'm sort of waiting for a few things to arrive, but the BPi PicoW S3, thank you, Oliver, did come the other day. That's what I can't even see what I'm doing. No, because I can't. Okay, you can see it on the screen anyway. That's fine. It was a bit awkward to get it running because you need to short a couple of pins. We're still not sure if the bootloader that comes on it is really the right one. But it's a powerful little board. It's just a little bit odd, I guess. It's in the shape, has the same pin. Well, it's meant to be pin compatible with the PicoW, but it's got an ESP-S3 on it. So yeah, interesting little board. I'll play with it and let you guys know what it's like next month. It is a shame that Jim's not here because he would love this board, I think. This is a chip shouter. And it's an EMFI tool, which is the easiest way to think this is a chip zapper. Generates a whole large chunk of voltage on the tip of it. You put it near your device and you can glitch your chips. It's used for fault injections or for testing how your device behaves under big zaps. There's a professional version of this, the chip shouter. This is the chip shouter Pico EMP, which is the one that you can see on the screen. The chip shouter is quite an expensive device, but it's also very well designed. It's the Pico EMP is designed by the same person, but it was intentionally designed to be a low cost version, and yeah, you could make one of these quite cheaply. It's built around the Raspberry Pi Pico, obviously, it's the name. You'll see the board's kind of got two halves to it. The left half there that you can see is all the high voltage stuff. The right side is just the micro. You can actually split the board if you want to use something else to control it. That's perfectly fine to do as well. There is C and MicroPython firmware, although the MicroPython stuff's pretty straightforward. It could do with a little bit more love there. You should go watch the video if you're into this kind of stuff. So it's, I thought it was a pretty unique use of MicroPython anyway. There's a pretty interesting thing too, where he's actually chip zapping another Pico, which just seemed a bit wrong. But, the Pine 60 OX64. This is a new board that's come out recently. I'm highlighting it not because it runs MicroPython yet; it's not out yet. But I think we'll see more of these kinds of boards, and that's to say that they kind of bridge the gap between something that's Linux capable, but also it's like you can use this as a microcontroller. And this thing's got 3 cores. It's got a high performance 64-bit core, a high performance 32-bit core, and a low power core, and they're all RISC-V. The pretty impressive thing here is that they're cheap, like $6 US for the RTOS version. They call it the RTOS version because it's only got 2 meg of flash, or you can get it for $8 US, where it's got 16 meg of flash and it's actually Linux capable. These are the cores that Alibaba have been working on for a little while. So this is the RISC-V cores that are run by that company, and they've been licensed by Buffalo Labs. So all 3 of those cores run to that little chip that's on that board there. There's also Wi-Fi built in, Zigbee, and Bluetooth. So for the price, it's a pretty astonishing little bit of kit. I don't know how we're going to make use of that for MicroPython. 3 cores. Managing 3 cores is kind of going to be an interesting challenge for any OS that allows ours. Had a look at a couple of LilyGo devices. I'll explain why in a sec, but I've got, I think, one of each of these next 3 boards on their way. The T embeds this, it's a Rotary encoder you can see it's a Rotary encoder with a display and a nice little package, some LEDs around it. Looks pretty nice. There's a GitHub for it, which is the main reason I'm sort of interested in the LilyGo stuff at the moment. They're going to some lengths to sort of support the devices with MicroPython in particular, but with drivers and that kind of stuff. So cover that a little bit more in a sec. But yeah, 33 US for this one. The TRGB, it's on these round displays that are sort of very popular at the moment. The interesting thing about this is it's 480 by 480, which is much higher resolution than most you'll see. They're usually about the 240 by 240 range. Built around the S3, presumably because it's got graphics acceleration and just shifting a few bits around there. Apparently it's got SPI and parallel support, so you can choose which way you want to drive it. I thought that was, I'm not sure if we've lost something in translation there, but anyway, it looks like both are supported. They also refer to a touch sensor, but I couldn't see it in the schematic, so I'm not sure if that's there either. But in any case, it'll be an interesting one to play with. Yeah, 36 US. Final one I'm looking at today is the T dongle S3, which is, you can see it in the picture, right? So USB-A with or without a display. Again, we've got an ESP32S3 in there, and it's just like one of those 1-inch displays, full color though. Pretty affordable. I'm really interested in all these because they're putting those repos together. They're also building on top of Russ Hughes' work. Shout out to Russ because he's been doing a few C drivers with MicroPython bindings, like MicroPython drivers written in C for a bunch of displays. And they're really fast, they're really well written. And so LilyGo have taken them and run with them, sort of they're integrating them into their own repositories. Their repositories could be structured a little better, perhaps based around the MicroPython example boards repository that Damien put together. But in any case, Stuart, I think you're on the call still. I know you were building these for the T-Display S3, so it'd be nicer if we could make that a little easier to build. But you know, kudos to Liligo. I mean, they're trying to get this stuff supported nicely, which is great. Speaking of Russ Hughes, he's also put a demo up on YouTube where he's comparing both of these are his drivers. The lower one runs the SPI driver, the upper one runs the 8-bit parallel driver, and it's honkingly fast, even from MicroPython. So, like, yeah, I'm really looking forward to playing with that. You could do things like Fourier transforms from audio. It looks like it could handle it very easily. Yeah, that only came out like yesterday too, so it was great timing. Thanks, Ross. Primarily have the automation mini board, which is for industrial control, mostly because it can handle high voltages, 6 to 40 volts, quite a wide range there. Has ADCs, digital inputs and outputs, has a relay as well. And really nice, neat designs we've come to expect from Pomerani. Shows things really clearly on the board as to what's going on. I like it. Haven't purchased one yet. I don't really have a need for it. Still want it. The Barcode HAT for the Pico. This is a board from SB Components. They're not cheap, these barcode readers. This one's $100 basically. But it's a pretty nice little barcode reader. The barcode guts is at the end there. It sprays out like a red line to show you where the middle of the barcode should be when it's reading. Does QR codes as well as 2D codes. It's really nice. It's a neat little board. Mutatrum, who I didn't know previously on Twitter, had put together a nice little solution for what they needed, and it was just it was like 100 lines of MicroPython to integrate with this thing. It's really simple and straightforward. Pretty neat. Core Electronics here in Australia have released another couple of PicoDev boards. These are designed to work with with MicroPython with their drivers. So they supply drivers for these things. There's also a really great video they've put together for the PicoDev Sketcher, which is basically an Etch-a-Sketch. And it's like 50 lines of MicroPython code that the guy from Core, I'm sorry, I've forgotten your name, it does a really good demo. He writes the code live while he's doing the video. It's really short, really quite interactive, just really clear. I won't say Michael, but Graham's the guy who runs Core. It's his business, but yeah, it's someone different, a younger guy that anyway, he does fantastic videos. He did great videos if you're out there watching this later. And so he's got 2 of these rotary encoders to do the X and Y axes on the Etch-a-Sketch. But a really neat thing was that you can't see it here, but on the back of the display, there's an accelerometer also plugged in, which is they released an accelerometer a couple of months ago. And he uses that for the shaking to clear. And even went to the, I don't know if you remember Etch-a-Sketches, when you'd shake them, they'd sort of fade away, sort of randomly. And he implemented that as well, included in that 50 lines of code. It's pretty impressive, pretty cool. Ken Tyndall has been working with CAN for a long time. I believe he's in the automotive industry. And the original model for this, which is the, what do they call it, the CAN Pico, came out May last year, which was basically a board that you could solder a Pico down to, which would give you CAN output. He's just been playing with the Raspberry Pi Pico W, so it can do Wi-Fi as well. And so this is looking really promising. So Ken also did a CAN implementation in MicroPython as well. So all of this, he's built all this around MicroPython, which it hasn't come upstream. I'm not sure if it ever will. Damien, you can talk about this later if you're still there. But he's published all the information. He explains how to build it and so on. The advantage, of course, with the Pico W is that it can talk TCP/IP and then spray that across to the CAN side. Later, hack your car, yes, Sandy. Yep. Anyway, this looks great. It's the original one was under 40 pounds, pretty readily available. I expect that we're sort of in a similar ballpark, maybe a little dearer. Software news. Espressif had their first inaugural DevCon, DevCon 22. There's a whole bunch of Espressif focused talks. A lot of Espressif engineers gave presentations, but there were also some good external ones as well. Probably the most relevant one was Limor from Adafruit, talked about CircuitPython on ESP32, because that's been a focus of theirs for CircuitPython 8, which is just coming out of beta now. So yeah, also Uri Sharkhead's Walkway talk is definitely worth a look as well. So yeah, go check that out. The new Darian Johnson, I know at least Andy and I have one of these devices. They're really neat. They've got those sharp hybrid displays, which is sort of a cross between an e-paper and an LCD. Sort of requires a little bit more power than an e-paper to hold its display, but it updates very fast. Really good for daylight readable stuff as well. Darian's been doing a lot of work for his default firm, which is C-based, but he has a GitHub discussions for this device, and Andy and I would like to see MicroPython on it. It's easy enough to get MicroPython running on this device. It's just an ESP32, or ESP32 S3 from memory. But yeah, it's getting all the peripheral control. There's capacitive touch. There's a display to worry about, that kind of stuff. So. Phil Howard, who was on last month, but gentleman from Pimaroni, had an example where he had like a web system that he put together and a multicolor, RGB LED display, and could draw on the web interface, and it just appears on the LED panel, which was really neat. It was really responsive, so it's basically as soon as you touch the pixel, it would appear. So he did a good job of the implementation. Go check it out. Project work, we looked at DIY Electro Music, whose real name's Kevin, I think, Kevin. Now this one's not necessarily, there's not a lot of MicroPython. I think some is in there. There's a whole bunch of stuff in here, like 11 Arduino Nanos, 6 Arduino Unos, etc. All of these like mini devices, and so he's driving this from a Raspberry Pi from memory, and basically making all these little things control little aspects of the MIDI stream. It's just an absolute delight to watch. So, and LEDs pop on and off, and the particular devices becoming active. Yeah, so I'd go check it out. It actually goes for like 20 minutes. There's a whole tubular bells from Mike Oldfield. Well worth a watch. I've been in touch with Kevin a bit. He's really keen to see more MIDI stuff in MicroPython, because I think he'd like to switch more of he's doing all sorts of boundary pushing with MIDI devices. So if we could enable him just a little bit, I think he'd take it and run with it. I hadn't come across Kayra before, but it's a project to make like an easy to modify. This is an easy to modify 3D printable open source humanoid robot. Only started in August, but legs are already off and running. This thing can do squats better than me. Yeah, it's pretty impressive. It can stand on one leg as well now. So there seems to be a bit of momentum behind this project. So if you're interested in robotics, it looks really cool. MicroPython based to control the servos. All of the stuff that you see in there on the corner is all open source in terms of CAD, STL. You can just go grab the files and print them straight away if you want to. A lot of thought's been put into the design of the that leg structure, so I think it's really good to look at if you're interested in the 3D side as well. Penguin Tutor, who I only found out today is also known as Stuart Watkus. He has put a couple of videos together. The one I came across was Hack Your ID Badge, where he looks at doing tic-tac-toe on a Badger 2040, which is a Pimaroni board. Well worth a watch. He sort of goes into quite a lot of detail about how to bend this device to your will using MicroPython. So it's pretty good. He's also got a few other videos. There's a tank game video as well, which uses a Pimaroni LCD display, which does the old Scorched Earth kind of game. Yeah, definitely worth a look as well. this article got quite a lot of interest. It was about getting a Raspberry Pi PicoW to connect to AWS IoT Core, because it kind of it made a lot of the awkward stuff understandable. So by awkward stuff, I mean making sure you get the certificates set up right, making sure your account sorted out in the Amazon side, and then making sure that your MQTT server is doing the right things to spit the data across to AWS IoT Core. Which, for those that don't know about it, it's a service that you can, like a lot of other Amazon services, you can hook into and store MQTT messages and get them to route through AWS. So, the Ferrofluid project from Simon, this was really cool. And I didn't realize until afterwards it was MicroPython. It might be a little bit hard to see here, but there's a tablet with a bunch of squares on it. There's a PCB here, and it's got a bottle of stuff in it. And if you haven't looked at ferrofluids before, they're like black magnetically activated fluid. So in that bottle, there's a bunch of this ferrofluid, and on the PCB, there's some controllable inductors which generate a magnetic field. So it's a pretty simple idea. Like, you have pads that match the PCB, and you can wiggle your finger over the pads on the tablet, and across a web server, it activates those pads on the PCB and makes the ferrofluid dance wherever you put your finger. Definitely worth a watch. Yeah, it's really cool. And Simon's done quite a few things with ferrofluids. It's worth having a look through his YouTube channel. And I was able to request, and the next day he posted all the code for it as well, which is, it's not much code. It's MicroPython. He built his own little socket-based web server just to receive whatever he needed from the tablet, and it works great. Although now he knows about Microdot, so we'll see. I'm hoping for a version 2 coming soon. Pybricks, I can gloss over that now because Lawrence has covered all of that. Oh, okay. LiDX and MicroPython, we've talked about LiDX a couple of times. You might recall it's a system to program FPGAs. This was a full example on programming an FPGA with LiDX, but adding a PMOD bridge. PMOD's a way to do peripheral modules. It's a pretty common standard in this world. The neat thing here is they've built like they can drop in, like, with 2 lines of code, create like an SPI bus across that PMOD. And this actual board here is actually a Raspberry Pi Pico, Raspberry Pi, sorry, I should say it's an RP2040 that's running MicroPython with SPI configured on the same port. So there's a complete example here where you can communicate to MicroPython over an SPI bus through to the FPGA with LiDX. It's really quite impressive how this hangs together. I think it's a really fascinating example because FPGAs can do things that, you can do accelerated calculations or whatever you need to specifically do. And this would be a little easier than putting your own micro down on the FPGA. So, quick bytes, we've got a few of these today. So in the MicroPython discussion, Zuli Rach talked about an IoT course that he created based on MicroPython. So he's got like a TWiki available and exercises, so go check that out if it's of interest. Guillermo Paletti recreated the Dino game. You might know the Dino game. It's just like this dinosaur jumps over things. He's published the code. It's what it looks like down here. It's a bit hard to see, but yeah. Also sort of, this resonated, I should get some rest on weekends. Also me, recreating the Dino game in RPi Pico is a good way to try MicroPython. And so you just don't rest. Pico Island had Max Vizard, or Max Vizard is going to give 2 talks on MicroPython at Pico Island. Go check them out. If you're in Ireland, go see them live. There's a cool plant monitor by Andrew Lewis. The interesting thing was he didn't want to use a digital display, so he made it all mechanical. So this is like an indicator here which goes up and down to show the temperature. And then there's a set of scales here. It's a bit hard to see, but this set of scales actually bends one way or the other based on the servo, depending on the humidity of the place. So this is going to be featured in the next Hackspace mag. It's all driven by MicroPython. Sort of related, Idea, I don't think that's his real name, did a plant watering device. It's really neatly laid out. Again, sort of showed how he did everything, which is pretty neat. Oh yeah, the rain gauge by Gel Victor. This has gone through a few iterations. There's one of these tippy things, so it tips one side and tips the other side, and you can figure out how much rain you've got. All the codes available. Go check it out. Scott Young has done a few projects with MicroPython recently. This was one I saw that I've got some of these little boards. They're a tiny little board that can decode MP3s from an SD card. Scott has then connected a Raspberry Pi to it, and you can control these boards over UART. It's one of the ways you can control them. So you can play your music files through it. You can see there's got a little headphone set up here. Neat. Really cool to hear the Adventures with MicroPython workshop is being run by the National Museum of Computing in the UK at Bletchley Park. So yeah, they're doing some analog interactions, so temperature and light sensors, which are both analog devices. They're showing people how to connect them, which I thought was really cool to see. And Rafael Roca did some really deep investigative work on the WisNet board, the W50, where he's put a bunch of data at it, thrown a lot of, done a lot of measurements about ping flooding and that kind of stuff, and just found that it was bulletproof. So I think Andrew worked on this a lot, so kudos to Andrew. It's really cool to see. Ubuntu announced support for MicroPython in their release notes recently. So 22.10 basically said that Ubuntu 22.10 now supports MicroPython and a variety of microcontrollers. Had to do a bit of a double take, but I think what it really means is they've got all the MicroPython tools which are commonly used are now available in the Ubuntu repositories. But it was kind of cool to see that in the release notes. So a page or two, and MicroPython got a Guernsey, which is nice. You might remember the Thumbie, tiny little, put it here, little device that runs MicroPython. The same people have made these Tiny TV 2s and Tiny TV Minis to Kickstarter at the moment. If you're interested in playing video, these aren't MicroPython as far as I can tell. They haven't really said how they're doing it, but given their background, I'm sure they're using the same sort of circuitry as the Thumbie. Oops. They're Arduino stuff. Thank you, Andy. Yeah. They're very cute. They're very small. Tobias Gresh presented MicroPython on the RP2040 at the Swiss Python Summit this year. Went into quite a lot of detail, talked about PIOs and DMAs and why you should really think about MicroPython instead of dropping into C. Like there's a lot more perf that you can get out of it if you use the hardware the way it should be used. Quite an interesting talk. Keith Mukai, this guy here with the red eyes, gave a huge recap on his recent MicroPython work. He's been doing a lot of stuff for a Bitcoin wallet called Seed Signer. But he's been doing a lot of really interesting work. One of the big things was that they had a lot of trouble getting STM32 devices, so they moved to MicroPython from C because they were getting hardware independence because they didn't know which microcontrollers they could get. And then he found that it was just easy to develop for anyway. So he's gone through a lot of pain with LVGL and display drivers and getting camera input. So it's interesting reading about that. And today he posted about his LVGL MicroPython experience at the request of one of my colleagues, where he described it as powerful but agonizing. So we might need to do some work there to try and make it a bit easy to use. Nearly at the end, folks. Axwax made a spooky eyeball. It's really cute. The eye wobbles around a bit. He also did an IncuPack project. This is another Pomeranian board, I think. It just grabs the weather and it displays it, which is quite cute. Mauser also published an article on the difference between Python and MicroPython, and it was quite detailed. So have a look at that. And I think this is the final one. Yeah, final one. I'm not going to try and pronounce Jude's surname, but he's got the progress bars implemented in the RPI Pico. It's yeah, it's 20. I think it's 23 lines of code. That includes like extra spaces here and there. And so the idea here is just an ADC read, checks what the ADC value is, and displays your progress bar as a percentage. That was it. The other things I want. This was kind of interesting because someone hacked this toilet. This toilet has a Bluetooth API. Why, I don't know. As far as I know, they weren't using. They were using some fancy BLE thing, but we could do this very easily in MicroPython now with our BLE stuff. So yeah, he hacked it, and then he could put the lid up and down remotely. So anyway, and this is a simple loop with Python, and the title was the name of the tweet, which is it's MicroPython, isn't it? And if you go look at the link that we've got here, this snake is actually curling around the box. The box is turning because of the snakes spinning around it. And that is it, my friends. Stop sharing.